Why is training data bias a problem for AI bug detection? Imagine building a robot that finds mistakes in your code. Now, if the robot only learns from a small or skewed set of examples, it might miss important bugs or flag good code as faulty. That's what training data bias is all about. When the data used to teach AI bug detection tools isn't diverse or balanced, the AI can develop a narrow view of what bugs look like. For example, if most training examples come from one programming language or bug type, the AI will be good at spotting those but might struggle with other languages or less common bugs. This means it won't work well in different coding environments or with new kinds of errors. Bias can cause the AI to make systematic mistakes. It might ignore certain bugs like concurrency issues or produce too many false alarms for bugs it overfits on. This reduces trust in the tool because developers want reliable results. If the AI keeps missing real bugs or raising false alarms, it can slow down the debugging process rather than speeding it up. Also, training data bias can reinforce old coding habits or outdated bug patterns. Instead of helping improve code quality, the AI might just repeat what it learned from past mistakes, which aren't always relevant anymore. Another problem is that real-world software is very diverse. Different teams use different coding styles, architectures, and tools. If the training data doesn't include this variety, the AI won't recognize subtle or rare bugs. It might overlook tricky issues that only show up in specific environments. This makes the debugging tool less useful for catching those edge cases. Bias can also influence fairness. Sometimes, training data favors certain programming communities or styles. This can make the AI less effective for developers working with less common languages or frameworks. It might seem like the tool is biased or unfair, even though it's just a result of the data it learned from. Knowing about training data bias helps you understand why AI bug detection tools sometimes miss bugs or give wrong suggestions. It shows why you should use AI as an assistant, not the only judge of your code. Combining AI suggestions with your own judgment makes debugging more reliable. Using diverse, well-curated datasets for training or choosing tools that are regularly updated can improve their accuracy. Testing AI bug detectors across different projects and environments helps catch bias issues early. To reduce bias, developers gather data from many sources, covering different languages, bug types, and coding styles. They also use techniques to find and fix bias during training, like fairness checks and bias reduction algorithms. Continuously adding new bug examples from real projects keeps the AI current. Including human review in the process helps improve the model over time. By understanding how training data bias affects AI bug detection, you can better use these tools to improve your coding. They become more reliable when you know their limits and work to make them better. This way, AI can truly support you in catching bugs faster and more accurately.